I am Anil Kumar. Welcome to my series on trigonometry. Let us understand another important concept with the help of the example. We are going to use substitution in a given formula to get trigonometric function. The question is before you. You can pause the video, answer this question, and then look into my suggestions. Enjoy the journey of success with me. You can always join my classes by sending an email on the address given. I am Anil Kumar. Welcome to my YouTube channel and the website Global Math Institute. In this video, we will understand a very important concept of writing trigonometric function using substitution. Here are 4 examples for you. You can always pause the video, answer the questions, and then look into my suggestions. In case you need help from me, you can send an email on the address given. Let us look into these questions one by one. Question number 1. Use substitution. X equals to 2 tan x, x is between 0 and pi by 2, to write square root of 4 plus x square as trigonometric function of x. Question number 2. Use substitution. X equals to 3 sin x for x being between 0 and pi by 2, to write 9 minus x square as trigonometric function of x. Similarly, we have question number 3 and 4. In this video, I am going to answer question 1 and 2, and 3 and 4 will be your practice questions. We also have similar videos where the questions are related. Here are 2 questions which you can also try and look into their solution in one of our videos. Prove the identity 7 sine cos inverse x equals to square root of 49 minus 49x squared. Now this is similar to what we are working on, but it gives you an idea as to how we can use the concepts learned in this video to prove identities. So that is how we leverage our learnings and apply the concepts in relation to the context. So let's begin with the solution of question number 1, which is use substitution. X equals to 2 tan x for x being between 0 and pi by 2, to write square root of 4 plus x squared as trigonometric function of x. So we have to use this substitution, which is x equals to 2 tan x. Now when we say within 0 to pi by 2, we are saying that it is in quadrant 1, right? So that means hello. So when we say that x is between 0 and pi by 2, it really means that we are working in quadrant 1 within 0 to pi by 2, right? So we are working in this particular quadrant where all are positive. It makes sense. Square root 4 plus x squared will be always positive and will be in quadrant 1, correct? Right. So now let's look into the expression given to us, which is square root of 4 plus x squared. Substituting x here, what do we get? We get square root of 4 plus 2 tan x, that is the value of x being substituted, whole square, square root. Now this is square root of 4 plus 2 square is 4, and we get tan square x. Clearly we can factor out 4. Once we do that, we get what? We get 1 plus tan square x. Now you can recall that this is one of the Pythagorean identities, correct? So we will now use the trigonometric Pythagorean identity related with 1 plus tan square x. 1 plus tan square x is equal to secant square x. Perfect? So that is what will be substituted here. So we can write this as, now 4, square root of 4 is 2. So I'll take it outside the bracket and I get secant square x within the bracket with square root. Square root of secant square x will be secant x. So that becomes the equivalent trigonometric function of x. Does it make sense to you? So that is how we can solve such a question. Now you can apply the similar strategy to do part 2. Let's look into this. We'll solve by substituting x equals to 3 sin x in square root of 9 minus x squared. You can always pause the video and do the needful. Substitution this time is x equals to 3 sin x in the expression square root of 9 minus x squared. That will give us square root of 9 minus 3 sin x whole square. And clearly, this is square root of 9 minus 9 sin square x. As we did earlier, we'll take 9 common. We are left with 1 minus sin square x inside the bracket, right? And square root of that. 9 can be factored out of square root as 3, and we have 1 minus sin square x in the bracket. Now 1 minus sin square x, as you know, is cos square x, correct? Pythagorean identity related is cos square x plus sin square x is equal to 1. And therefore, 1 minus sin square x can be written as cos square x. So within the bracket, we have cos square x, which gives us the result 3 cosine of x. You see that? So that is how we can actually do these questions. I hope that makes sense. Feel free to write your comments, share your views. If you like and subscribe to my videos, that would be great. You can always contact me on the address given here for any help. Thank you and all the best.